Okay, we're on section 1-4, prime factorization. Okay, when you've learned this from other teachers, you may have learned the tree method for prime factorization. I'm going to allow you to use that if you really like it. I don't actually think that it's the easiest method to use, so I'm going to show you kind of another way. Okay, so one thing you have to really be good at is your divisibility rules to know where you even start. All prime factoring is breaking down a number into its smaller pieces. Okay? When you make a recipe of anything, when you bake a cake, it doesn't just come out, even when you buy a cake mix, everything's not in there. You still have to add eggs and oil and water, right? You're just breaking that menu down into all of its ingredients. That's all you're doing when you break down a number with prime factorization. Okay? So you need to keep dividing until you can't divide anymore and you're at only prime numbers. So let's start with 175, and I'm going to show you one method to do that. So the minute you see that 5 on the end, that should kind of be a red flag to you that you can take a 5 out of that. So I kind of came up with this new way to divide things, and I want you to just kind of try it on for size. So the first thing I'm going to have you do is we're going to divide that by 5. Okay, and I'm going to turn it into a fraction. So first thing I want you to look at is, it's like doing long division but without all the hassle of long division. Okay, so look at, does 5 go into 1? Well, we know that doesn't work, right? Now go to the next one over. Does 5 go into 17? You say, yeah, well, must be that does go into 17. So that goes in, and write it over here. 5 times 5 is, 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15. So I know it goes in 3 times, but that's 15. I'm trying to get it into 17. So how many do you have left over? So 17 minus 15 is 2. I have 2 left over. I'm going to write that right up here, kind of in between that 7 and 5. Because that's what I had left over from the 7, so I'm not going to give that to the 5. So now I'm actually going to look and see how many times 5 goes into 25. Okay? And 5 times 5 is 25. So already I've broken it down that in order to get 175, that is 5 times 5 went into 175 35 times. Okay? So I've already broken that down like that. 5 times 35 is 5. Now I know that I can break down 35 into what? Well, in order to get 35 broken down into its smaller pieces, I just need to break that down into 7 times 5, and then add on that 5 that I already divided out. So 7, 5, and 5 are all prime numbers. You're done. Right at that point, you're done. And if you want to check it, 5 times 5 is 25. If you had 7 quarters, you would have $1.75, which is 175 cents. And that's the same amount that you started with. Okay, it's just a different way of breaking it down. If you really want to break it down with a tree form, you can definitely do that. But that's, I think something always kind of gets lost when we do that. But I'll show you a tree form just so you have that example. Okay? So the tree form would be if you started with this, and we already know we could take the 5 out, and we decided that was 35. When you get to a prime number, you need to circle that. I think that's a big thing that people don't do, and that's why they kind of miss things. And then 35 you can break down into 7 and 5. Those are both prime numbers, so you stop. I also think that the tree factor kind of takes a little bit more room, but it's your preference, whatever you want to do. As long as you can do prime factorization correctly, I'm going to let you handle that the way that you want to handle it. Okay? So let's try 235. So let's see if any of our other divisibility rules apply. So 5 definitely does. So we can start with 5 if we want to. I really would like you to try this method of division of the dividing by 5. Really all you're doing is, instead of doing division like you always have, which is not really very algebraic, you're turning it into more of an algebraic function. So, which is going to help you down the road as we get into algebra concepts. So you're going to divide it by 5. So let's try this again. So does 5 go into 2? No. Does 5 go into 23? Definitely does. If you needed $23, you could have some $5 bills in there. So 5 times 4 is 20, so I know it's going to go at least 4 times. So 5 times, oops, sorry about that. 5 times 4 is 20. Out of 23, that means I have 3 left over. So I'm going to stick that little 3 right there. And then I'm done with these two now. Now I just need to look at 5 into 35. And 5 goes into 35 7 times. So 47 times 5 is where I'm starting with that factorization. Then I got to figure out if 47 is a multiple of anything. And if you go through your factoring rules, and if you use that multiplication sheet that you have in front of you that we worked on the other day, which you should definitely have in your notepad, 47 is actually a prime number. So this is as far as you can go. So 47 times 5 is the prime factorization of 235. Okay? All right, next one I want you to try on your own. And I want you to look at that and think, okay, what's at least one number I can put in there? And see if you can just start with that. Okay? Go ahead, hit pause, try that on your own, and then come back and check it against what we've got in the notes. Okay? All right, so for me, the easiest thing to take out of that would be a 2. So instead of writing it below, I'm going to do this. Okay, 2, I know it's 2 times something. I can split 344 in half, right? So I know that 2 goes into 3 one time, has 1 left over. And I don't need to look at this now because I already dealt with it. 2 goes into 14 7 times, right? With nothing left over. So now I don't need to write anything up here because I took care of all 14 of that. 2 times 7 is 14. So I'm done with this now. Now I just need to look at how many times 2 goes into 4. And that's the easiest of all. It goes in 2. So 2 times 172 gives me 344. So the 2 I'm done with. Now let's do that again. This ends in 2 again. I can take another 2 out of that. So let's break that 172 down. And you're going to do the same thing. Okay? And if you want to write it right below, that's fine. So 2 goes, try and do it now without writing it down below like that. So 2 can't go into 1. 2 can go into 17. 2 times 8 is 16. So that's going to go in 8 times with 1 left over. We're done with this now. And then I got to figure out 2 goes into 12 6 times. Okay? So now I've got 2, the original 2, and then I just split 172 into 86 times 2. So far so good. So now 2 is prime, 2 is prime. I just need to keep breaking this one down. I can break that one down again because it ends in a 6, so I can take half of 86. So I want you to think about another way you could do that. So split that up, okay? You've got an 80 and a 6. When you add that together, you get 86. Well, let's do half of that. So I can split 80 in half, and I get 40. Let me rewrite that. If I divide that by 2, I get 40. And if I divide 6 by 2, I get 3. So let's add that up. So half of 86 would be 43. So now, what I have up here, I have my original 2. My 86 turned into 43 times 2. And then I have this 2 right here. Okay? Now we've got to think about, can I break that 43 down into anything? And it turns out that I can't. 43 is a prime number. Not divisible by 0, 2, 4, 6, or 8, because it doesn't end in a prime number. 3 plus 4 is 7, which means it's not divisible by 3, 6, or 9. And 7 doesn't go in there. 7 times 6 is 42, so close, but not quite. So your prime factorization of 344 is going to be 2 times 2 times 2 times 43. You'll eventually get to the point where you're going to write that 2 to the 3rd power times 43. And I just want you to put that in your notes for now. We're not doing it yet, but it's just something good for you to put in the back of your mind for a little bit. Okay? All right. All right, last one, and you're going to do this one on your own, and then come back and check with me. So hit pause, try it again, and then come back and check. Okay? All right, so for this, I'm going to take half. So I'm dividing it by 2. 2 goes into 2 once. 2 goes into 5 twice, with 1 left over. Get rid of those. 2 goes into 16 8 times. Okay? I'm going to do that again. 128 I can split in half. So 2 times 2. I'm taking the 2 out of this 128. 2 can't go into 1. 2 can go into 12 6 times. And 2 can, I don't have anything left over, so those are gone. And 2 can go into 8 4 times. Now, if you're getting good at your multiplication, you're going to recognize that 64 is a multiple of something. And that is actually a multiple of 8. So bring down your 2's. 64 is 8 times 8. Then you've just got to figure out what you can break 8 down into. 8 breaks down into 4 times 2, right? Each one of those does that. So you've got 2 times 2, but now each one of those 8s turns into a 4 times 2 and a 4 times 2. Are we at all prime numbers yet? Well, we're not quite, because 4 is a composite number. So each one of those is going to break down into 2 times 2. So now, this is where you got to keep track. So that's a 2 times 2, and that's a 2 times 2. So what do you have now? You've got 1, 2, 3, 4, 5, 6, 7 2's. So you can write that 2 times 2 7 times, or that is written 2 to the 7th power. Because that exponent means exactly what we just wrote. 2 times itself 7 times. Okay? Good job. That's it.